Welcome to Maths for E channel. A past question on series. Let f r function of r equal 1 over r plus 1 squared, and u r a common term of a series, r plus 2 divided by r plus 1 squared time r plus 3 squared. R is an integer, positive integer. Show that f r function of r minus function of r plus 2 equal 4 ur. Let's start with the first part of the question. F r function of r equal 1 over r plus 1 squared, and ur is given 2r plus 2 divided by r plus 1 squared, r plus 3 squared. We need to find our function of r minus function of r plus 2. Prior to that, find function of r plus 2. So all you are doing, just substituting r plus 2 instead of r. So function of r plus 2 is 1 over r plus 2 plus 1 squared. 2 plus 1 is 3. So 1 over r plus 3 squared, that is function of r plus 2. What we need to find, function of r minus function of r plus 2. So function of r is 1 over r plus 1 squared. Function of r plus 2 is 1 over r plus 3 squared. LCM is r plus 1 squared times r plus 3 squared. The first one, if we divide the LCM by r plus 1 squared, what we left with, r plus 3 squared. So r plus 3 squared minus, second part is the LCM divided by r plus 3 squared. So what we left with, r plus 1 squared. So this one is similar to like a squared minus b squared. If a squared minus b squared, we can write a plus b and a minus b. That is exactly what I have done here. So r plus 3 is a, r plus 1 is b. So first part, a plus b. So r plus 3 plus r plus 2. So that is, that's the first one. The second one, r plus 3 minus r plus 1. So the r plus 3 minus r minus 1. The r cancelled out from the second part. The first one is 2r plus 4. 2r plus 4 times 3 minus 1 is 2. So 2r plus times 2, the denominator is still the same, r plus 1 squared times r plus 3 squared. The top part, or the denominator, we can take 2 out. We already have another 2. So 2 times 2 is 4. What we can put inside the bracket is r plus 2. So this, and then denominator r plus 1 squared times r plus 3 squared. But we know r plus 2 over r plus 1 squared times r plus 3 squared is ur. So 4 times ur. That is what we've been asked to prove. The next part, hence. So obviously the strong, the hint to use that first part. Show that sigma r equal 1 to n ur. So the series from 1 to n equal 13 over 144 minus 1 over 4 times n plus 2 squared minus 1 over 4 times n plus 3 squared. So we need to prove it with the help of first part. So the first part, we have proven the 4 ur equal fr minus fr plus 2, or whichever you want. Right, it's from ur, we can write 1 over 4, it's just divided by 4, f function of r minus function of r plus 2. So when r is equal 1, so r equal 1 and 2 and so on, r equal 2, r equal 3 and so on. So when u1 equal 1 over 4, r equal 1, so f1 function of 1 minus function of 3. Then r equal 2, u2 1 over 4, function of 2 minus function of 4. And the third one, 1 over 4, function of 3 minus function of 5. And if you could write all the way, And then before ending that, I start with this un minus 2 equal 104 fn minus 2 minus fn. And then the next one, r equal, this is r equal n minus 2, r equal n minus 1, r equal n. So, so U2 is 104 function n minus 1 minus fn, and r equal n minus 1 un minus 1 equal 104 fn minus 1 n plus function of n plus 2. Then u equal n 104 function of n and minus function of n plus 2. If we look at it, if we add them, because we need to add them at that the left hand side, that gives you sigma of n1 to n r1 to n r1 to n r1 to n ur. That is when you actually add them, u1 plus u2 plus u3 plus up to un, which will give us the sigma r1 to n ur. That's the left hand side. Right hand side, we know, so when you add it, we have to add one by one. So when you look at it and you add it, the function of 3 is minus here, the first one, when r equal 1. When r equal 3, function of 3 is there positive. So that will be cancelled. So if you look at it, if we, the first part, if function of 1, function of 2 left, the rest of them cancel until the last two on the other side is function of n plus 1, function of n plus 2 left. So the sum of that a series, sigma r equal 1 to n ur equal 104 function of 1 plus function of 2 minus function of n plus 1 minus function of n plus 2. That's, so the rest of them will be cancelled out. So if you could do that, 1 over 2, function of 1 is n equal 1, which if you substitute that, we know function of r, if you substitute that, 1 over 2 squared, function of r is given, is 1 over r plus 1 squared. So if you substitute that, 1 over 1 plus 1, 2 squared, and then 1 over 2 plus 1, 2 plus 1, 3 squared. And the other two, n plus 1, n equal n plus 1, 1 over n plus 2 squared minus 1 over n plus 3 squared. This one, first one, 1 over 4 outside the bracket. The first part is 1 over 2 squared is 4, 1 over 4. 1 over 3 squared is 9, 1 over 9 minus 1 over n plus 2 squared minus 1 over n plus 3 squared. So in further simplification, 1 over 4 and the number, if you look at it, 9 and 4, that's LCM for that is 36. Therefore, is the first part is 9 plus 4 and minus 1, for just multiply by 1 4, so remove the bracket, 1 4, 1 over n minus 2 squared minus 1 4, 1 plus n plus 3 squared. Just 9 plus 4 is 13. So 13 over 4 times 4 times 36 is 144. 13 over 144 minus 1 over 4 times n plus 2 squared minus 1 over 4 times n plus 3 squared. So that's again the second part we have been asked to prove with the help of first part, which we did, and that's has been proved. Right, next part, it says that deduce that the infinite series, when r1 from 1 to infinity, ur is convergent, and find its sum. So you need to prove that r from 1 to infinity, the sum of the series is a defined number or defined quantity that's convergent because of this series going to infinity, but the actual sum of it, it's a number, and that's value, right? if you do that, we know that sigma 1 r from 1 to n is 13 over 144 minus 1 over 4 times n plus 2 squared minus 1 over 4 times n plus 3 squared. Now substitute, now as n becomes infinity, so r from 1 to infinity, therefore n is in infinity. The first part is same, 13 over 144. If you substitute n for the other part, is n plus 2, that is n plus 2 is infinity. Anything divided by infinity is 0. And again, same thing, n plus 3 is an infinity. Anything divided, 1 divided by infinity is 0. Therefore, that's out. So we have 13 over 144. It is as a number or defined number. And the series r from 1 to infinity is convergent. And its value is 13 over 144. And another part in the question, it says let Tn equal sigma from r from n to 2n, not from 1 to n to 2n ur, and show that limit of Tn when n tends to infinity is 0. Right, let's do that. So it says n to 2n. We need to find n to 2n, but Tn is given sigma from r from n to 2n ur. And limit of n tends to infinity, Tn is 0, we have to prove. We know, so what it is, this is sigma r from 1 to infinity is ur equal 13 over 144, which already proved in that part before. That's convergent, right? Okay. Now, simple approach to find. Instead of finding that, to find that r equal n from n to 2n, we can think of r from 1 to 2n as a complete series from 1 to 2n, and then it's r from 1 to n minus 1. So I just somewhere here, n minus 1. So just there. So this part is 1 to 2n, and this part is 1 to n minus 1. So if you subtract the whole thing minus up to 1 to n minus 1, that is exactly what we are doing here. Sigma r from 2n, the whole thing, and minus sigma r1 from n minus 1, same thing, isn't it? R from n to 2n is equal sigma r from 1 to 2n, the big part, minus the front part is r from 1 to n minus 1, and the rest is r from n to 2n. Then this is the part we need to find. So, in other words, Tn equal sigma r from 1 to 2n ur minus sigma r from 1 to n minus 1 ur. So if you substitute, or if n tends to infinity, so this is r from 1 to 2n is infinity 2. If n infinity, 2n definitely infinity. So r from 1 to infinity, ur. Again, r from 1 to infinity, ur. We already know r from 1 to infinity, we proved it here. R from 1 to infinity equal 13 over 1 over 144. So this is 13 over 144. The next one is 13 over 144. 1 minus 13 over 144 minus 13 over 144 is 0. That is exactly what we have been asked to prove in that last part of the question. Tn equals 0 when n equal infinity. Thank you. Please subscribe the channel and share the contents with fellow students. Thank you.